ke dekat UTM?
Memang dulu dekat Skudai, doktor.
Okey, baik. Hakim Rafi'i Shah Alam. Ni Shantini Penang. Nur Hanani mana ni? Nur Hanani. Muhammad Azmi Kota Baru. Muaz Sulban. Muhammad Amirul Farid Sulong. Muhammad Afiq Coklat. Nur Iskandar Negeri Sembilan. Nur Iskandar Kasim mana? Aishman. Nur Hanani Bengka. Nur Iskandar UTM. Oh, Iskandar dah balik UTM ya.
Dah balik.
Fairul Izwan. Fairul kat UTM ke dekat mana?
Kat rumah.
Oh, rumah Skudai. Dekat mana Skudai?
Dekat Taman Stroket.
Taman apa?
Taman Stroket.
Oh, Okey. Oh,
Mm-mm.
okey, baik. Ahmad Syazwan. Mana ni? Kuantan faham. Okay, so berapa orang dah balik? Okay, so for your information, mungkin kamu dah tahu juga okay, you are allowed to come back to UTM. Okay, just need to apply to come back to UTM Okay, if you are not convenient studying at home, okay, you can request or apply to come back tahun 3, tahun 4. Okay, diberi priority juga untuk datang balik. Syamir dari Pekan. Syamir Amirul. Muhammad Anas dari Kelang. Okey, nanti sekejap apa lagi. Muhammad Fahmi daripada Melaka. Okay, seronok tak duduk lama-lama kat rumah? Tension tak? Abdul Harzan. Di mana? Sentul, Kuala Lumpur. So saya kenalkan diri saya Muhammad Kamil bin Abdul Hamid. Saya dari Jabatan Otomotif. So saya kena ambil session kamu lah, session 4. Session 5, session 5. So saya akan I will be assisting. Okay, so yang penting you kena work hard. Okay, I will just going to assist you, okay, to pass the course. Okay, so component design a bit tough the subject. Okay, sebab require combination of all the things that you have studied before: static, solid mechanic 1, solid 2. Okay, so we will perform some revision. Hopefully akan refresh your previous punya knowledge. Muhammad Firdaus. Okay, don't forget to scan your attendance. Okay, I have provide the QR code, okay, for attendance. Okay, make sure you scan. Muhammad Afiq atas Tamish. Okay, so I plan to, okay, if you see in the class, for the class, ada dua session. Okay, one is on Sunday and the second one is on Tuesday. Okay, so dua-dua pukul 8 pagi. Okay, so 8, 10 dan 8, 11. Okay, so okay, satu is lecture, satu is studio. Okay, that supposed to be the normal punya condition of the course. Okay, tapi dimandangkan sekarang ni banyaknya daripada online. Okay, we will make some adjustment. Okay, so okay, for on apa ni, on Tuesday punya class, okay, we will start from 9 o'clock. Okay, Sunday tu boleh lah, tak apalah pukul 8 kan. Tapi for Tuesday ni kita start pukul 9 lah. Because we have 3 hours punya session, panjang sangat. Pengsan. Semalam saya punya session pun dah 2 jam setengah. Lepas session tu je dah apa ni, penat lah. Okay, so ada berapa orang ni? 18 orang ni datang. Bertuah ni budak. Okay, so okay lah, 11 lah. Ni lagi tak nak masuk. Okay, so saya nak share screen. Okay, so I will brief you on dia punya information, course information sekejap. Okay, so for this class, SEMN 3523 Component Design, sesi 2020-2021 ni, semester 2, okay, we have actually banyak section. Okay, we have about, I think berapa, 10, 11. Okay, so you are section 5. Okay, so penyelaras is Dr. Mr. Afandi bin Zakaria. So all the tests, even the assignment will be standardized. Okay, so there is assignment, quizzes, projects. Okay, mostly will be standardized. Okay, so ada many lecturers for different section. Okay, penyelaras is Mr. Afandi. Okay. And then, okay, 3 credit hours. Okay, so banyak ni, minggu-minggu ni banyak. Okay, so in general dia punya guidelines, okay, week 1, fundamental concept of component design. Okay, ada introduction, design process, Newton law, 2 force member, 3 force member. Okay, 2 force member, 3 force member masa static dulu. Okay, FBD, force and moment, shear force diagram, bending moment diagram, torsion diagram. Okay, this is from static, dynamic. Okay, kemudian week 2, static failure prevention. Okay, ada introduction, maximum stress theory, maximum shear stress theory, distortion energy theory. Okay, ini ada more circle tu. Okay, on solid mechanic punya. Okay, it is related to your solid 1 and 2. Okay, and then week 3, fatigue mechanics, failure prevention. Okay, so fatigue, satu static failure, satu fatigue failure. Okay, fatigue mechanical failure. Kemudian the fatigue mechanical failure prevention, itu sambungan dia lah. Okay, and then gear, spur gear, design of mechanical element 1, dynamic performance of spur gear. Okay, itu is related to gear lah, kita akan buat gear force analysis. kemudian on bolt. Okay, kemudian permanent non-permanent joint pakai bolt, dan bolt kan boleh buka pasang kan. So non-permanent joint, kemudian the permanent joint pakai welding. Okay, kemudian semester break. Lagi ada masuk Farhan. Ini Muhammad Farhan. Muhammad tak ada Muhammad Farhan. Muhammad Farhan. Okay, itu apa tadi? Saya punya. Okay, so I think week 7 weeks. Ada test 1 lagi tak mention. Week 7 I say test 1. Okay, kemudian semester break. Kemudian week 9 bearing selection. Okay, on bearing ada two different types of bearing. Okay. Kemudian belt, V-belt selection. Kemudian ada pasal spur gear, again spur gear, pasal dia punya strength. Okay, kemudian sambungan week 12, week 13 shaft. Sorry. Okay, so this is the one first slide, lecture slide that I have shared with you. Okay, so ini pun standard lah sebenarnya for all the section. Okay, so mind over matter. Okay, this is for you to understand. Okay, never mind and doesn't matter. Okay, can be a good or negative statement. But if you take it, you flip it and take it on the positive side. Okay, so you should be good. Okay, never mind and doesn't matter how difficult the subject is. Okay, I will perform with flying colors atau I will pass with flying colors. Okay, so component design a bit tough, but never mind and doesn't matter how tough, how difficult the course. Okay, use your mind, okay, and be positive. We will help you to pass the course. Okay, so I mentioned kita ada lecture and studio. So sekarang ni we just going to be lecture studio. We might be macam buat some exercises, class homework, classwork. Okay, during the studio time tu lah. Okay, so I will just use both time. Okay, lecture dan studio lebih kurang je lah. Okay, we will have some session exercises during classes. Okay, my name Muhammad Kamil bin Abdul Hamid, C2347, bilik saya pun dah lama tak pergi bilik. Banyak jin agaknya kat bilik lah. Okay, my email. Okay, so chapters. Tadi chapters per year. Okay, shaft tadi yang last night shaft is going to be skip. Okay, there will be no shaft actually. Dalam course information tu ada shaft at the end. Okay. Tak ada. Last kali update post content ni tak ada. So just sampai spur gear. Untung kamu sikit. Tak masuk shaft. Okay, so these are the assessment assessment involved. Test 1, okay, for the first part tu nanti will be the topic test for test 1. Okay, and then test 2, test 1 30%, test 2 30%, minor project 10%, major project 20%, homework 5%, classwork 5%. Okay, all the marks only be valid if your attendance are 80% and above. Okay, if you miss the class, we might just fail you. You miss too much, okay, of the classes. Okay, so that is the deal. Okay, this is the textbook, not daily. Okay, yang penting, okay, for the class, okay, we are going to use book by Robert Juvenal. Okay, Robert Juvenal dan Kurt Marshall. Okay, so Juvenal book ah. Okay, so please try to get, actually itu yang apa ni, ini edition, I think 5th or 6th edition. Right now actually we are using buku ni khas lain. We are using this okay, this book now. Okay, component design. Okay. Okay, this is the 7th edition, the latest. Okay, fundamental of machine component design. Okay, Robert Juvenal and Kurt M. Marshall, Asia edition. Okay, so I have shared dia punya link for you to get the book if you want to get the book. Okay, it is not compulsory to get the book, but it will help a lot. Okay, but if you can get any copy, okay, apa ni online copy punya, tengok ada yang website that can provide you with some good apa ni buku on component design dan by Juvenal. Okay, ini 7th edition. If you are using 5th edition, still okay. Kamarul baru masuk. Okay, so that is the okay. So the main thing is the reference. Okay, the main reference must be using you must use the Juvenal punya buku. Okay, Robert Juvenal. Okay, because there are some differences. Okay, if you, for example, use book by Shigley, okay, ada buku sebelum ni we were using Shigley, buku by Shigley. Okay, so some difference in terms of parameters dan constant. Okay, so starting, okay, some introduction or some short brief introduction. Okay, so it is called design of machine component, okay, ataupun design of machine element, because we are looking into the parts, okay, the elements, the component. Okay, after this you are going to look the design process at the system level. Okay, this is on the component level. Okay, so these are the stages. Okay, ada stage dia. So this is on design of machine component. The component design is a subject deal with the plan, construction and analysis of machine component. Okay, maknanya we are going to, we have to make some judgment, okay, and look into the suitable of the component in terms of the material. Okay, so it will involve selection of material and the process use, okay, in fabrication, okay, so of that machine component. Okay, so construction, kemudian we will perform the analysis, okay, to check whether it is good enough, okay. Then we might combine the selection, okay. So and then, okay, so we have to check, okay, on the component punya strength, the GDT, okay. So all these are like the standard factors that we need to check for the component, okay, in the selection of the material, okay. And then of course, okay, every component we also need to check for the reliability, durability, okay, from different kinds of material. For example, if the component is expected to operate at extreme temperature, okay, so we might, okay, really need to look into very thermal resistant punya material. Okay, so this kind of condition, okay, we need to consider in our design of the component process. Okay, so kemudian of course, okay, component design, satu we need to see the strength, kemudian of the dia punya capability of the component, okay, in terms of the life cycle, okay, what is the capability, how long it can last, okay, that kind of factor consideration need to be included. So that's where, okay, the analysis on the fatigue, okay, failure, the static failure, fatigue failure, because we would like to check, okay, what is the life cycle, okay, of that component, okay, what are the first, what are the strength, and then what are the how reliable and durable, okay, of the component. And then of course you have to look into cost juga, okay, because you might have a very unique, very not very strong component material used for your component, okay, then you don't have to, I mean, with your limited budget sometimes, okay, you just need probably just to find enough the strength for the material, okay. So the component, okay, machine component involved, okay, can be in terms of the bolt, nut, bracket, clutch, brake, spring, welding gears, belt, chains, ropes, okay, so many lah. Okay, the main thing ada banyak, okay, and we need to check dia punya strength and dia punya apa ni, dia punya capability to stand all these different kind of load, okay, and then dia punya life cycle. Okay, these are the examples, okay, mechanism ataupun object component that you will come across and analyze. Okay, for example, ada this some rod that you will rotate the rod, okay, apply the load. In the first picture on the left, okay, you have your hand, okay, providing the load P, okay, to rotate, okay, to move the rod, okay, and then you have your bearing at point B, bearing at B, and bearing at point D, okay, and then another load is applied at point C. Okay, so you need to, okay, to check, okay, and of course, okay, actually this is related to your FBD, okay, so the FBD, free body diagram, okay, so it will involve a lot of FBD, okay, free body diagram. Okay, these are example free body diagram. Okay, bearing, dekat bearing, at bearing B, okay, if you recall for bearing, okay, mesti ada two component of the reaction force. Okay, so Bx and By, for example, Bx and Bz, sorry. Okay, so X direction and Z direction. Okay, and then Dx and Dz juga. Okay, so you have two reaction forces. And then so just yang lain-lain biasa je lah. Okay, so FBD. So you have to come up with the FBD. Okay, the second ni apa ni? Another bearing with a pulley. Okay, and then you have a sometimes you might come across apa this moment. Okay, so moment at the point B, the second picture, you might need to identify what are the moment produced by the force F2 on the right picture, and then identify MBX, MBY, and MBZ. If you have moment produced by the respective load ataupun forces. Once you have your forces, then you might need to consider and check for the moment. So in component design nanti it will include modification of different part of the cars, bikes, and etc. Meaning, for example, dekat bicycle, we will be looking into, for example, the chain, dia punya rantai, the chain of the bicycle. What are the load involved? What are the maximum stresses? And what can we do to improve the capability of the chain of the bike? And then identify dia punya life cycle dia, fatigue, capability of the fatigue. So that is that kind of analysis will be you have to perform. And then ada join. Apa join ni? So join anything, any parts, joining the two this is example given two bogies of trains. So joins normally involve the bolt, the permanent and the non-permanent. So nanti kita tengok tu lah bolt dan juga weld of the component. Kemudian it also include designing of material for reducing their weight. So right now many engineers, we cannot run away from looking into what they call the smart material. We need to find very strong material with lightweight and strong material. So this kind of selection analysis, in order to get or to select material, will be considered, and used, in order to design our component. So these types of component design, we have adaptive, develop, new design, ni boleh baca saja. So what are the respective different types of design? In general, ada adaptive design. Mostly nowadays involve this kind of design. Adaptive design, develop design, and new design. Abdul Hazan, can you give example adaptive design? Can you think of example of adaptive design?
Adaptive design, main dekat board anak.
Apa contoh dia macam mana? Sebut anak tu.
Contohnya modification yang kita buat dekat design dia. Tak pun dekat size dia.
Design dekat size dia. Okay. Okay. Ahmad Luqman. Apa lagi contoh adaptive design? Dengar tak? Ahmad Luqman. Luqman tak dengar eh? Mana Ahmad Luqman? Ahmad Syazwan. Dia dah putus.
Ya saya.
Pasal tu, okay. Ada bising sikit. Example, adaptive design ataupun develop design. Adaptive design, develop design. Berdengung sangat eh. Bising sikit. Tak apa Ahmad Syazwan. Hakim Rafi'i. Boleh tengok contoh. What is the example? Can you give example? Can you think of adaptive design or develop design ataupun new design? Boleh lah mana-mana aja. Hakim. Dengar tak Hakim?
Dengar. Sekejap
Masuk ni. Muhammad Muizzuddin. Mana Muizzuddin? Muhammad Muizzuddin baru masuk. Muizzuddin daripada mana Muizzuddin? Mana Hakim? Senyap tu
component design. Dia macam design ni dia komponen saja ke the whole thing? Contoh yang nak diberi tu.
Anything, boleh dua-dua boleh. Komponen boleh, whole product boleh.
So contoh kalau mouse untuk komputer tu daripada wire jadi wireless tu kira develop design ke macam mana? Ke adaptive design?
Can be adaptive, can be develop design. Okay. So it is not a fixed punya answer lah. Okay. So the main thing, if you have a product, benda tu dah ada, and then we try to modify and improve. Okay. And then you just like adapting some small changes, okay, to improve the product or improve the component. Okay, that falls under this adaptive design category. Okay, kemudian develop design, okay. Kalau dah ada design, existing design banyaknya, based on macam tu lah kan, you have already the design and then you using that kind of design, okay, we develop Mostly nowadays, okay, component or the product adapt ataupun apply the first one lah, okay, adaptive design, okay, kemudian develop design pun ada cost, and then new design pun ada lah, okay, but mostly nowadays because most of the products are available, they just require some minor modification to improve, okay, the existing design. Okay, kemudian, okay, thank you Hakim. Okay, so there are many actually, okay, many, for example, methodology. Okay, so in solving this design, katakan apa ni approach lah, okay, for machine component problems, okay. So in this, for example, okay, you can have this 11 step, okay, to find the need, or okay, what is the need, okay, in terms for you to develop ataupun to design your component. Okay, define the need, okay, and then defining the problem. Okay, one is the need. What is the need? Apa keperluan dia? Kemudian you have the problem. Okay, you might you fulfill the need, but still got some shortcoming ataupun problem lah. Okay, and then we have to define the problem. Okay, define the mechanism involved. Okay, making appropriate assumption. Okay, remember in your design process mesti ada assumption. Okay, it is very important. Okay, because what happen is that assumption will simplify kita punya design process, and at the same time actually to make sure that the design is still valid. Okay, sebab if you try to design or perform analysis on the complex punya design, okay, you can get stuck lah, because sometimes, okay, we can simplify and still produce good reliable punya, for example, the acceptable maximum stresses, okay, for the bolt, for example. Okay, so defining mechanism, kemudian making appropriate assumption, analysis of forces, material selection, design of machine component, checking the reasonableness of the result, modification in design, detailed drawing, production or manufacturing. Okay, so these are the step lah, okay, and methods, okay, in solving machine component problem. Okay, so sampailah, okay, dia punya production lah. Okay, so there are many stages, okay, methods. Yang pentingnya you understand lah, okay, the design process requires, okay, complete ataupun detail lah dia punya stages tu, nak kena check, okay, what is the need, okay, define the problem, define the mechanism involved, so that every component tu will be worth and to be produced. Okay, so in analysis, definitely it will involve, okay, these different kinds of areas. Okay, static, dynamic, mechanics of material, okay, formulas, okay, it will involve conservation of mass principle, conservation of energy principle. Okay, in addition, engineers need to know how the physical characteristic of the material of which component are fabricated relate to one another. Okay, and then nanti masuk the Newton's first, second law of motion, okay, and then the third law. Okay, nanti kita tengoklah banyak kena apply third law, Newton's third law tu, action and reaction. Okay, opposite, okay, every action there will be the reaction. okay, the same magnitude but in the opposite direction. Okay, so that will be again, okay, involved, okay, dalam component design ni lah banyak. Okay, and then case ada heat transfer equation, ini just for your apa ni, for general information. Okay, Fourier's conduction model. Okay, this is for the real punya practice for designing the component. Okay, assumption will usually be necessary to simplify the problem. Okay, so assumption is important because it will assist or help us to simplify the problem. Okay, make certain that equation and relationship are appropriate and valid. Okay, so we have to actually biasanya kena buat simplification tu sikit, tidak tak habis nak buat calculation tu. Okay, and okay, in general ataupun the approach that we use in this class, okay, especially this is actually related to your nanti project. 7 step in organizing the solution. Okay, number 1, what are the knowns? Okay, what are the things that information that you know? Okay, and then find what are the things that we need to find, and then we have to come out or provide schematic and given data. Okay, what are given, and then decision and what is to be carried out, what kind of analysis, okay, and then what are the assumption. And then we perform analysis, and then last we provide the comments, okay, for your problem. Okay, this is example. Okay, example for solution. Okay, organizing the solution, the problem solution. Okay, known, what is known? State briefly what is known. Okay, what is the problem all about? Okay, pasal kereta ke, pasal dia punya transmission ke? Okay, is it about transmission? Okay, so just state. This requires that you read the problem carefully and understand what information is given. Okay, what kind of analysis need to be done. Okay, fine. State concisely what is to be determined. Okay, what is the things that you need to answer. Okay, whether it is the maximum stress that you need to find. Okay, whether it is the torque produced, okay, by the shaft, ataupun the life cycle. Okay, what is the value of the life cycle you need to determine. Okay, and then the third, schematic and given data. Okay, sketch the component or system to be considered. Okay, decide whether a free body diagram is appropriate for the analysis. Mostly, okay, remember dalam komponen ni memang FBD itu is important lah. Okay, you draw your FBD. Okay, get your FBD right. Label the component, okay, with relevant information from the problem statement. Okay, record all material properties and other parameters that you are given, okay, or anticipate may be required for subsequent calculation. Okay, sometimes you need some to find additional information. If appropriate, sketches diagram that locate critical points and indicate the possible mode of failure. Kita tengoklah maknanya what are the things required. Alif Haikal masuk. Okay, so the importance of good sketches of the system and free body diagram cannot be overemphasized. They are often instrumental in enabling you to think clearly about the problem. Okay, so first step, okay, if possible, these are the dia punya arrangement, organization, yeah, and you need to organize. So today's day, what are the known, find, schematic. Okay, this is especially bila buat punya minor project nanti. Okay, because in the classes, the exercises, nanti kita just going to perform the calculation. Okay, I might not be, okay, will depend on the problem lah nanti. Okay, so schematic and given data to make sure you have your sketches, FBD and related drawing. Okay, decision, record your choices and selection. Design problem will require to make subjective decision. Design decision will involve selection of parameters such as geometry, variable and types of material. These are individual choices. Azimi, Muhammad Azimi. Dengar tak Muhammad Azimi? Dia punya statement ni, they mention decisions are individual choices. Kenapa agak-agak? Azimi dengar tak? Muhammad Azimi bin Muhammad Razi. Azimi dengar tak? Mana Azimi? Tak dengar ke Azimi? Okey, tak apa Azimi tak dengar pula. Afiq Abdul. Dengar tak Afiq? Ada tadi? Sorry.
Ya, sudah.
Ini tentang decision. Part decision. Okay, they mention decision are individual choices. Apa makna dia tu?
Apa dalam kefahaman saya, decision ni kita sebabkan dia untuk individual decision, individual selection. So ni pada apa yang saya fahami, mengikut pada kita punya ni design. Contohnya kalau design tu ada problem ke, so jadinya kita yang akan decide sama ada kita nak ubah apa manfaat yang problem ataupun kita buat minor macam buat minor
Modification.
changes dekat part yang problem. So sebab tu dia panggil individual decision. So kita yang decide kita nak ubah atau tak, sama ada ubah dalam segi size ataupun dia punya mekanisme.
Okay, baik. Okay, so terima kasih Hakim. Apa pula Hakim tadi? Afiq. Okay, so of course, okay, when you perform your calculation analysis nanti, okay, there will be like macam apa ni, option. Okay, there will be like sometimes not one answer ataupun one combination. Okay, you might be using, you can have macam 2-3 combination, okay, of your component. Okay, and selection will be based on you punya needs or requirement. Okay, for example, you might need very good katakan bulk, okay, but you punya you punya bulk is limited by the space, katakan the size dia. You can have the range from 0.1 for example to 0.2 cm, okay, and then the combination of that, okay, with the other component, okay, will be based on the requirement, okay, of your problem. Okay, meaning you might need you might not be required to have very high precision for your design in your component. You might require a bolt that probably kurang sikit dia punya kuat dia. Okay, so based on your requirement, okay, and then based on For example, your limitation, cost ke ataupun spaces. Okay. And then we will perform the decision lah. Okay, so based on requirement on your problem. Okay, so decision are depending on the individual choices. Okay, what are your priority? Kan you nak high precision ke? Kan kadang surface dia punya surface machining tu kan of that part kan probably tak perlu very high smooth dia. Okay, and then you might combine with different parameters. Okay, just to ensure enough or adequate component to withstand any load for that kind of problem. So normally it will be based on the requirement and then based on your priority lah, your limitation in your problem component. Okay, and then assumption, to form a record of how you model the problem. List all simplifying assumption and idealization made to reduce it to one that is manageable. Sometimes this information can also be noted on the sketches. In general, once a design is complete, assumptions are still believed, whereas decisions are true. Assumptions are theories about reality. Okay, yang pentingnya you have to tahulah assumption tu, and mostly all these assumptions kan you kena tengoklah contoh-contoh kan the similar problem. Okay, for example kereta, kereta related to the transmission, and what are the assumption, not the common ataupun standard assumption dealing with the operation of the transmission. Kan ada dia punya inertia, whether it is going to be included in your transmission analysis. Sometimes dia kata dia neglect, the inertial forces of that transmission is assumed to be small or negligible. In order to simplify and then for you to be able to perform your analysis lah. Masuk macam-macam masuk might be makin susah dan makin banyak problem lah sebenarnya. So assumption is important so that it can assist in simplifying the design. As long as remember the calculation ataupun dia punya end result tu is still in the acceptable punya range ataupun values. So normally memang you have to find lah the common ataupun the standard assumption for respective problem. And then you perform your analysis using your decision, assumption and idealization. Apply the appropriate equation to determine the unknown. It is advisable to work with equation as long as possible before substituting in numerical data. Ini nak masuk numerical analysis. Consider what additional data may be required. Identify the tables, chart or relationship. Provide the required value. Additional sketches may be helpful at this point to clarify the problem. Faham ke? When all equation and data are in hand, substitute numerical values into the equation. Carefully check that a consistent and appropriate set of units is being employed to ensure dimensional homogeneity. Kena tengok, check dia punya unit. Then perform the needed calculation. Finally, consider whether the magnitude of the numerical values seem reasonable and algebraic signs associated with the numerical values are correct. So this is analysis tu lah. Make sure analysis perform, you are using the right equation. And then if require some additional sketches ke apa, buat lah. Kemudian check for the unit. Make sure you are using the right unit kan. Kadang kena to transfer ataupun change the unit into the SI unit. If you wrongly use the unit, then you end up with a different answer. Okay, so and then check the magnitude, is it reasonable? Okay, your final tu kadang can, what are the normal punya maximum stresses for example untuk that kind of problem. You can double check kalau besar sangat ke atau kecil sangat. Then you can know that some problem in your calculation in the unit ke. Okay, so that kind of thing that you need to check. Okay, and then last comment. Okay, when appropriate, discuss your result briefly. Comment on what was learned, identify key aspect of the solution, discuss how better result might be obtained by making different design decision, relaxing certain assumption, and so on. Okay, these are the seven steps. Okay, all these 7 steps. Organizing the problem solution. Okay, this is nanti kena buat lah, kena pakai untuk you punya minor project ni. Okay, these are the units. Okay, so just make sure you are using this standard unit. Okay, so SI unit, and then jangan lupa lah tukar. Okay, they give you in different non-standard, so you have to change it and use the standard unit. Okay, ini example. Siapa ada ni? Amirul Zainal. Amirul Zainal daripada mana?
Ya doktor,
Amirul daripada mana? Sekarang ni duduk kat mana tu?
duduk dekat rumah.
Rumah kat mana?
Rumah kat Terengganu.
Terengganu kat mana tu?
Dekat Kuala Terengganu.
Terengganu. Boleh tak Amirul bacakan soalan ni?
Boleh. The 300 lb loaded weight car shown in figure 2.1 is going 60 mph, and at this speed the aerodynamic drag is 16 horsepower. The center of gravity and the center of aerodynamic pressure are located as shown. Determine the ground reaction force on the front of rear wheels.
Okay, terima kasih. Okay, so this is example. Okay, soalan tadi, kemudian this is the, tengok dia punya approach for ni. Okay, so ini yang proper punya lah. If you have a question and then known, what is known, a car of specified weight travel at a given speed with known drag force. Apa komponen dia? Ni lah komponen not daily lah. Ini lebih kepada overall punya FBD. Okay, for you to identify ataupun refresh balik lah, revise some related on FBD ni kan. Okay, so okay, in this example, okay, you have the known, find, determine the pavement force on the tires. Okay, pavement apa tu, forces on the tires. WR dengan WF, and then ada FT dekat bawah tu. Okay, FT, and then you have your CG. At CG is your weight, 3,000 pound. Okay, and then you have your FD. FD is the drag force due to the wind. Okay, acting on CP, center of pressure. Kemudian you have the car with velocity 60 miles per hour. 60 miles per hour. Okay, so this kind of FBD, okay, you need to be able to produce. Okay, FBD of the kereta tu. And then assumptions. The speed is constant. The car has rear wheel drive. Okay, that's why FT, okay, is at the rear wheel. Okay, from the, katakan from the engine, the rev tu, okay, that power is being transferred to the wheel, and traction FT, force traction. Vertical aerodynamic, forces are negligible. The rolling resistance of the tires is negligible. Okay, so that is the assumption. Power is force times velocity. Okay, power force, FD force to F force times velocity. Okay, and 1 horsepower. 1 horsepower it can be, tengok unit dia tu 33,000 feet pound per minute. Okay, and then 60 miles per hour is equal to 5280 feet per minute. Okay, so okay, this is the equation untuk horsepower tu. Okay, so horsepower is equal to the force, drag force times velocity divide by 33. So you get the horsepower, okay, in terms of horsepower unit lah. Okay, so you are given the car is having apa, the power 16 horsepower. So 16 horsepower equal to FD times velocity divided by 33,000. Okay, you get your FD value. Okay, FD value is the drag force lah. Okay, FD value is 100 pound. Okay, once you get your FD value 100 pound, okay, you can use that FD value and then using the summation of forces in the direction of the motion. Okay, for example, to the right, positive. Okay, and then the summation, the total forces in the motion, in the direction of motion is 0. So FD plus FT equal to 0. So FT is equal to FD equal to 100 pound. Okay, this is the force applied by the road surface to the tire. Okay, the force applied by the tires to the road is equal but opposite in direction. Okay, that is the thing. Okay, that's Newton's law. Okay, Ft is 100 pound in the forward direction. This is the force applied by the road surface to the tires. The force applied by the tires to the road is equal but opposite in direction. This force is divided equally between the rear wheels for the rear wheel drive car shown. It could be applied to the front tires for a front wheel driver car without altering any other forces. Okay, so because we are using with the assumption the rear wheel drive. Okay, so FT tu dekat rear wheel lah. Okay, kalau front wheel tukar ke depan. Okay, and then applying the moment equilibrium equation with respect to moment about and exist passing to the rear tire rods contact. Okay, taking moment dekat tayar belakang tu. Okay, taking moment, summation of moment equal to 3,000 times 50 inch. 3,000 is the weight. Okay, so taking moment at point WR tu lah, WR and FT tu. Okay, at that point you have 3,000 times 50 inch, okay, positive, and then negative WF times 100, and then negative FD times 25 inch. So, okay, lebih kurang. Okay, so then you can solve for WF. Okay, apa ni? You punya force at the wheel, front wheel, 1475 pound. 1475 pound. Okay, so and then finally from the summation of vertical forces equal to 0, okay, we use the summation of forces. Okay, vertical forces 3,000 minus 1475, you get 1525. This is the rear wheel punya force acting on the tire. Okay, vertical punya force. Okay, so that is the involved calculation. Apa lagi nak cerita? Okay, tengok baca ni comments. Before leaving the problem, we note two further point of interest. The weight of the vehicle when parked is carried equally by the front and the rear wheel. Okay, kalau kereta tu tak berjalan, if the car is not moving, then WF will be equal to WR. Okay, 3000 divided by 2, 1500. But when traveling at 60 miles per hour, okay, now the car is traveling at 60 miles per hour. Forces FD, the drag force, and FT introduce a front lifting couple. Okay, kamu tengok it is a couple about the lateral axis. Okay, axis perpendicular to the paper in figure 2.1. Axis perpendicular to the paper of 100 pound times 25. Kamu tengok apa ni? Okay, so maknanya the couple tu lah. Okay, so FD dengan FT tu is macam couple. Okay, dia pun the same magnitude with opposite direction. Okay, with the distance 25. So that produce a apa ni dia cakap tadi? Couple. Okay, introduce a front lifting couple. Okay, front lifting couple. So dia akan macam rotate kan. So at the front tu dia akan macam lift lah. Okay. So this is balanced by an opposing couple created by the added force of 25 pound carried by the rear wheel and the reduced force of 25 pound carried by the front wheel. Okay. So kamu tengok, okay, when the car is moving at 60 miles per hour, WF is 1475 je. Okay, WF is 1475, WR is 1500, 1525. Okay, WR 1525. Okay, so different of 25 pound. Okay, that is the force actually that is balancing, okay, the couple. Okay, this is balanced by an opposing couple created by the added force of 25 pound carried by the rear wheel and the reduced force of 25 pound carried by the front wheel. Okay, note this simplified analysis neglect vertical aerodynamic forces, which can be important at high speed. Okay, hence the use of spoiler and wings on this car. Okay, so that's what happened. Okay, what happen bila lebih tinggi, the speed is higher, okay, dia punya lifting couple tu become higher. Okay, that's why you require some apa ni pushing down of the vehicle, of the car. Okay, dia panggil the okay, spoiler dan wing tu lah. Okay, in order to actually keep the vehicle or car to the ground. Okay, because to cater for this lifting couple. Okay, and then the second point, the thrust force is not in general equal to the weight on the driving wheel times the coefficient of friction, but it cannot exceed the value. In this problem, the wheel will maintain traction as long as the coefficient of friction is equal to or above the extremely small value of 100 pound divided by 1525. 100 pound to is the FT value, 1525 is the WR. Okay, so that is the apa ni, the traction force divided by weight. Okay, so to maintain traction, okay, the friction must be above, okay, equal or above, okay, that the two values. Okay, 100 divided by 1525. So okay, what is important, okay, you need to actually, for this example, ialah FBD, okay, FBD, and then we need to check, okay, we have to identify assumption, use the right analysis, calculation, okay, and then perform the analysis and provide your comments. Okay, so this is the complete way of solving your problem. Amirul Shah. Okey ke? Ada soalan? Amirul Shah daripada mana? Amirul Shah. Mana Amirul Shah?
Ya saya Doktor. Saya daripada Pak Sulong, Johor. Ha.
Senang tak? Cakap ni.
Ya cikgu? Ya Doktor.
Senang, okey. Faham?
Faham insya-Allah.
Okay, so okay, this is example 1. Kita akan tengok next one. After this, the second part. We will have a short break, 5-minute break sekejap. Okay, and then we will continue. Lepas ni, okay. So, boleh break 5 minit sekejap. Thank you. Stop sharing. Okay, kita akan sambung sikit lagi. Kita buat ni. Sharing. Okay, so apa ni? Anas dah masuk ke belum Anas? Dengar tak Anas?
Dengar tu.
Anas daripada Kelang
Sorry.
Anas dekat Kelang, duduk Kelang ke?
Ya betul Doktor.
Okay, okay tak apa. Okay, kalau kamu tengok, okay, saya rasa okay kan semua ni tak ada yang kena share kan. Okay, so for untuk component design ni, okay, we are moving from static kan to solid mechanic dan dalam static we were trying to solve for FBD determinate problem. Okay, makna dia you have to check okay the numbers of unknown tu is apa ni match lah dengan numbers of equation. Okay, kemudian in solid mechanic 1 well, normally calculation involve solving indeterminate problem and stress of combined loading. Okay, kemudian solid 2 on Moore circle. Okay, Moore circle to represent various combined stresses into one equivalent stress. Okay, untuk kelas component design, it will involve all, semua masuk. Kemudian we are going to calculate for safety factor. Okay, radius of the shaft based on the given material. Yelah, shaft ada dekat sikit tu lah maknanya, yes. Okay, so yang main thing is your FBD, kemudian nanti kita akan tengok Moore circle, okay, and the stresses lah. Okay, static dan kita punya cyclic stresses. Okay, this is just short apa ni revision lah. Okay, so forces kita ada can be Fx, Fy, Fz, arrow with single head. Okay, you can have this apa ni this term. Okay, you can just combine F equal to 10I plus 20J plus 30K. Your Fx, Fy and Fz. Okay, and then we have your moment. Okay, moment and torsion. Sometimes tengoklah moment ke torsion kan. Moment and torsion, arrow with 2 head. Okay, so ada arrow, ada 2 kepala tu, the two head. Okay, 2 arrows. Okay, on the direction of rotation. Okay, this is where important for you to tengok pakai the right hand rule. Okay, the right hand rule. Okay, so ada for example MX, MY and MZ. Okay, so recall balik. Okay, please. Okay, if you have your thumb for example kan, the right hand thumb pointing X direction. Okay, that is the direction of the moment. Okay, and then the rotation is on that axis. Okay, using your finger tu lah. Okay, so that your finger, the other 4 fingers represent the direction of the rotation. Okay, so we can have mx, my, and mz. Okay, and then torsion and moment. Torsion and moment the same, and why they are named differently. Okay, you can please recall balik, refresh balik. Okay, moment and torsion, what are the different? Okay, so if you have a cylinder, okay, you can represent your cylinder and then and check for dia punya moment mx, my, and mz. Okay, this is another cylinder. Okay, for example, you have a cylinder A and B, OA and OB, mx, my, and mz. Okay, depending. Okay, you can find mx, my, and mz. What is the total moment? Okay, what is the total moment? In the case of cylinder OB, for example. Okay, so double arrow. Ni dia punya head tu kan, double arrow for moment. Okay, the direction and kemudian dia punya rotation. And remember, most of the time, we will involve FBD with kita punya equilibrium. Okay, so the total summation of forces, total summation of moment, in respective direction, will be zero, and the total pun nanti zero lah. Okay, and then just recall all the different support and connection. Okay, free body diagram. Okay, DBA. Okay, at point D tu. Okay, of course you punya apa tu? Pin joint. So just one force pointing upward at point B. Another cable pointing downward at point A is your pin joint. Two forces, reaction forces. Okay, so quickly some revision. Okay, refer to and the draw force acted based on the joint. Okay, and then determine whether the FBD is statically determinate or indeterminate. Okay, so check the number of unknown. Okay, so this is the step. For example, okay, you have your FB. FB tahu the value is known. FB equal to W. Okay, if W is known, then leave you with FD, okay, and then FAX and FAY. Okay, so ada three unknowns, and then we have three equations. So it is okay. So boleh solve. Okay, can be solved. Okay, with equation. Okay, FBD determine the forces and moment at the wall. Okay, if you have a cylinder, kemudian at the end of the cylinder you have this forces F, okay, the shear forces or the force F, and then the axially force P, and then you have a torque T. Okay, determine the forces and moment at the wall. At the wall tu dekat support dia at point A. Point O lah biasanya cakap origin of that. Okay, so what do you have? Okay, for the forces F, okay, at the support, ataupun at the wall, okay, we will have the same magnitude but opposite direction. Okay, the red color arrow F, okay, at the wall. Okay, and then for the force, the black arrow P, okay, at the wall, at the support, we are going to have Okay, the red color arrow. Okay, opposite direction. Okay, opposite direction. Okay, so ada F and P. Okay, the red color, just the opposite of the black arrow. F and P. Okay, T is torque and it is not a force, therefore it has no effect this equation. Okay, for the force, this is just for the force. Okay, and then if we go for the torque, okay, moment or torque, when equal to 0, torque, the reaction at the wall will have the same magnitude and in the opposite direction. Okay, this is the important part. Okay, please try to recall and understand. Okay, for the top T, the black T, the black arrow T, okay, we are going to have, okay, opposite direction. Okay, rotation, opposite rotation is going to be, okay, the thumb will be pointing towards negative x, the axis. Okay, so you have your torque, okay, in the opposite direction, okay, the red arrow. Okay, and the arrow, okay, the T, the red arrow T with double arrow, okay, that is your torque, okay, at the wall, okay, due to the torque, the black arrow torque, okay, and then, okay, and then you have another, okay, moment ataupun moment, okay, due to force F, okay, the black arrow F, okay, the black arrow F, okay, from the point, from the wall, it give you the distance of 100 mm. Okay, and then, okay, if you see on the smaller apa ni gambar ni, kan gambar ni you find ada gambar, okay, gambar tangan ni. Okay, the right hand rule where you need to, okay, you can apply, okay, apply for force F tu, okay, the black arrow F. So the black arrow F, okay, the black arrow will be represented by your apa ni, your punya 4 fingers tu lah. Okay, the close 4 fingers, and then the direction is pointing toward positive y axis. Okay, so the moment is going to be F times 100. Okay, F 100, okay, from the black arrow is pointing upward. So at the wall is going to give the opposite direction. So the double head, double arrow tu, okay, double arrow 100F, okay, is pointing downward. Okay, is pointing downward in relation to the opposite direction. Okay, because yang F, the black arrow F tu is going to produce moment in the direction of y positive. Jadi at the wall, okay, it's going to counter that, okay, with the moment 100F pointing downward. Okay, so this kind of apa ni FBD, reaction forces, okay, at the support, okay, need to be practice. Okay, and then force P to the black arrow force P will not result any moment, okay, because that force is going along the apa, is the distance is 0 from the wall, kan, it is the point to is hitting or it's touching the point. Okay, so it's not going to produce any result, any moment. Okay, so you have moment due to force F, the black arrow F, and then the torque tu is apa ni, is due to the black arrow T. Okay, so that is for, and then for the combined equation, combine for the forces and the moment, okay, combine forces and moment and torque tadi, okay, we will have this arrangement. Okay, the free body diagram of the cylinder, okay, at the wall, if they ask you to find the free reaction, the free body diagram and the reaction at the wall, okay, you will need to draw. Okay, so you will have 100 F pointing downward, negative Y direction with double arrow pointing downward, and then the red arrow F pointing positive Z direction, and then you have the red arrow P, okay, pointing to the negative X, and then you have the red arrow with double arrow, double arrow T, okay, pointing negative X direction, okay, and also dia punya rotation tu lah kena draw juga okay, dia punya apa tu rotation. Okay, so that is the the case combined forces and moment. Okay, so this kind of problem nanti will be asked in the test 1, question number 1. Okay, so this kind of problem, okay, you need to identify IBD dia, kemudian and then after that calculation ni lah masuk sikit. Okay, okay, this is exercise. Boleh tak apa dah ni? Tak apalah, we setengah. One example exercise, determine the free body diagram at A and B. At point A and point B. At point A tu dekat dia support dekat the wall. Theta is given 30 degree. Px is 200 Newton. Okay, from point A is fixed to the wall. Okay, so tengok macam mana nak solve dia. Okay, this is the answer. Kita buat reverse engineering. Okay, so for Px, okay, that Px is causing Px is 200. Okay, at point A tu in terms of force is going to give you the same but opposite direction. So P 200 Newton at point A tu. So due to Px, okay, positive X direction. So PA tu is 200 Newton opposite direction. And then okay, and then we have to find Px too, that force Px is going to cause moment. Okay, use your right hand rule. Okay, and then identify. For example, in terms of M1. Okay, M1 tu is okay, M1 is 200 is your Px value. Kemudian 75 sin theta. Okay, is the vertical distance. Okay, vertical distance, perpendicular distance of that point Px2. So 75 sin, okay, and then okay, Px, take your right hand, kemudian okay, the thumb is pointing toward negative Z direction. Okay, Z direction, negative Z direction. And then to counter that at point A, you have to counter that direction. You get your M1 pointing towards positive Z direction. Okay, and use the double arrow. Okay, so M1 is 200 times 75 sin theta, sin 30. Okay, so that is the value of moment A. Okay, M1A lah. Okay, kemudian that is in terms of apa? Distance Y. Kemudian for X, distance X from point A, okay, dia punya perpendicular distance you have to use 100 plus 75 cos theta. Okay, and then use your right hand. Okay, your right hand for PX tu will be pointing, the thumb will be pointing downward. Okay, will be pointing to Y negative. Okay, so to counter for that, okay, at point A, it will counter for the PX. Okay, you have your positive direction, the double arrow M2. So the value will be 200 times the distance is 100 plus 75 cos 30 tu. Fahmi ada tak?
Ada doktor, ada.
Okey tak? Boleh faham? Boleh dapat?
Faham doktor.
Okay. Fairul Izwan,
Ada doktor, ada.
boleh dapat?
Boleh.
Okay, so that is for point A. Okay, kemudian itu dapat moment M1, M2. Kemudian using the equation, formula ni, MT, M total. Okay, you can calculate M total at point A. Pakai rumus M1 square plus M2 square square root. Okay, you get your moment total at point A. Kemudian, okay, that is for point A. Firdaus okey tak Firdaus? Muhammad Firdaus. Dengar tak Firdaus?
Okey doktor.
Okay, Firdaus daripada mana?
Melaka doktor, Melaka.
Melaka. Okay, so that is point A. Kemudian tengok point B. Point B sama juga. Okay, so now you just need to cater the same step. You tengok, okay, from point B, okay, what is the moment caused by the force PX? Okay, tengok value sama, okay, cuma, okay, the term at point B, okay, the PX is countered by the shear force V, pakai V, because it is considered as shear force. V equal to 200 Newton, okay, that V is countering PX, okay, the force on the opposite direction of that PX, okay, and then T is apa tadi? T is your sama macam M1, okay, so but consider as T, okay, so just your vertical, okay, vertical 20 apa tadi, 200 times 75 sin 30. Okay, so that is the consider as dia punya at point B. Okay, kemudian dia punya M moment, okay, yang vertical moment tu pun sama juga lah. Okay, so it is the apa ni, force, the shear force and moment and torque at point B. So this kind of approach step kan you kena familiarkan cara ni, okay, in order to identify, okay, your ni macam internal force lah, okay, due to the force. Okay, last example before we finish. Berapa dah ni? 40. Okay, this is actually soalan daripada PEXA. This kind of You have bearing, kemudian ada pulley. Okay. So pulley ini normally involve torque. Okay, and then moment tu normally involve dia bending moment lah. Okay. So apa ni? A and D is supported by the bearing. A and D bearing. Kemudian B dan C ialah pulley. Okay, and then given bearing are subjected to radial. Okay, determine ini dia punya body diagram, dia punya torque T1. Okay, and we need to solve for T1 and T2. And then solving for dia punya force diagram, shear force diagram dan moment diagram dan juga torque diagram. Okay, so satu lagi types of apa ni problem ataupun benda yang disuruh cari, you have to produce is the apa tadi, shear diagram, shear force diagram. Okay, so and then before that, okay, kita kena tengok maknanya kena solve for T1 and T2 ni. So you are given as macam mechanism this component, you ada bearing at point A, bearing at point D, kemudian ada pulley at point B and pulley at point C, Okay, dekat pulley B ada dua cable, tarik tu 1200 Newton and 200 Newton ataupun cable ke force, cable. Okay, the two forces 1200 Newton and 200 Newton, and then dekat cable dekat pulley C, okay, pulley C pun ada dua juga, T1 and T2. T2 is 0.15 T1. Okay, and then apa nak buat? Okay, ini dalam soalan ni sebenarnya dia suruh kita solve for T1 and T2 and then produce shear force diagram. Okay, and what happen is that kalau jenis this kind of problem, okay, we need to start drawing FBD. Okay, still with FBD. Okay, tapi what happen is that, okay, looking at dia punya orientation of the problem, and for example pulley tu ada dua pulley, satu is pulley tarik ke atas, forces dia tarik ke atas, and then the second pulley dia punya forces is pointing in the Z direction. Okay, we can perform FBD using plane XY and plane XZ. Apa ni? One of the method to solve the FBD is looking the problem based on the plane, Okay, for example, plane XY, okay, plane XY dan plane XZ. Okay, so this is the technique. Okay, draw FBD. Ini sebenarnya related to your FBD. Okay, you ada this problem, ada bearing, ada pulley with the forces acting. Okay, what to do? Okay, draw FBD using respective plane. For example, plane number 1, plane XY. Plane XY, moment about Z axis. Cakap moment about Z axis. Okay, moment about Z axis. Plane XY. Plane XY. Okay, X and Y. Okay, so since F di atas, okay, the cable dekat pulley B tu naik atas, okay, tambah dua-dua, 1200 plus 200 Newton. Okay, because the two forces acting pointing upward, 1400 Newton. Okay, at point O, the bearing, okay, the first bearing, okay, you can draw or assume FOY pointing downward. Kemudian the other bearing FCY pointing downward. Ini ada sikit mistake lah sebenarnya. Okay, sebab dia pakai O. pulley is A, patutnya B. Okay, and then the second pulley patutnya C. Dekat FBD ni tulis B pula. Okay, so please aware. Okay, so that is the first. Okay, once you have your this FBD on from plane XY, okay, plane XY. Okay, so moment about Z axis. Okay, so Z axis tu you punya thumb tu lah pointing towards Z direction. Okay, and then you can solve. Okay, taking moment at point O, FOY tu, you can solve for FCY. Dapat FCY and then solve for FOY. Okay, so this is one FBD dia. Kemudian plane XZ. Plane XZ, okay, orientation tu je, kena tukar sikit. Now, dekat point, the second pulley tu, okay, ada dua force T1, T2 tu. Okay, T1 and T2, okay, pointing downward, kita consider positive Z direction is pointing downward. Okay, and at the bearing O pointing upward, and then bearing C pointing upward. Okay, so we can we can samalah sebenarnya step dia sebenarnya. Okay, we can solve for T. Okay, T is equal to 1.15 T1. Okay, why? Kenapa 1.15 T1 tu tambah dia lah sebenarnya. Kan T1 is 1, kemudian T2 is just 0.15 T1. So total up 1.15 lah T1. Just the problem is to find T1. Okay, so T1 is actually you need to calculate. Okay, calculate T. Ni tak saya tengok dia ni solution ni. Okay, so don't worry. Okay, untuk ni you have to actually find. So just quickly share. Nampak tak? Okay, yang tadi tu jelas sebenarnya kita kena solve for T first. For T1 is okay, total summation of T top tu tadi tu TA plus TB equal to 0. Okay, so the T can be solved. Okay, 1200 is going to be the new force times the new radius of the pulley. Okay, so since kita ada 1400 tu, one side of the pulley is 1200. So yang besarnya 1200 minus 200. So that will cause the rotation. Okay, because 1200 kan dia lebih besar pada 200 tu. So it's going to overcome, and so that's why kena tolak tu 1200 divide tolak 200 and then times dia punya dia punya radius of the pulley. Radius of the pulley is 200 diameter divide by 2. Okay, kemudian okay, so katakan that is positive direction, and then positive direction, kemudian yang T1 T2. Okay, so T1 is greater than T2, so T1 minus T2. Okay, so T1 minus 0.15 T1, okay, times the radius. Okay, so T1 to radius dia is 150 divided by 2. So you can solve for T1 daripada okay, equation the total summation of the top tu. Okay, so the key is to kita tahu dia punya total summation of the top is equal to 0. Okay, along ini we consider plane XY lah. Okay, plane XY. Okay, so just take that kind of approach. Okay, once we get solve for T1. Okay, and then tadi dapat T lah. Okay, so T1 you get your T1. T1 is 1569. Okay, so that is the approach for Muizzuddin, boleh ke Muizzuddin? Ada soalan? Tapi belum habis lagi lah tadi cerita dia tu. Okay, tapi yang penting dia punya is your FBD tu satu. Okay, so in this problem, the main thing is to show you example of the FBD using the two plane. Okay, so you can use FBD XY plane, kemudian XZ plane, okay, to solve your problem. Then dia akan, okay, based on the plane ni dapat tadi. Okay, the second one, once you get your T value, dapat T value dia, taking moment at point O, solve for FCZ, kemudian total summation of vertical forces equal to 0. Okay, you can solve for FOZ. Okay, kemudian okay, so ni tadi lah. Okay, yang plane XY tadi, plane XY. Okay, recall balik untuk shear force diagram. Okay, dapat FOY tadi 891. 891, so turun bawah for shear forces. Turun bawah 891 and then straight line and then naik atas 891, naik atas lagi. Total up is 1400 Newton. Okay. Kemudian shear force all the way to the right is 509 Newton. Turun bawah balik 0. Okay, and then that is the shear forces. Kemudian moment diagram. Okay, you can use the area under the shear force to calculate your M maximum, MA for example. Moment at point A is just 891 2 times 200. Okay, 891 times 200, negative value are negative. Okay, and then point B pun sama 150 times 509. Okay, you can get your MB value. Okay, so that is approach dia. Okay, ni yang besar sikit, sorry. Okay, so shear diagram, moment diagram. So benda ni akan tengok lagi lah. Muiz dengar tak Muiz? Okay tak? Ada soalan? Farhan, Nur Farhan.
Dengar.
Ada soalan tak? Muiz, okey tak?
Okey, doktor. Sekarang ni okey.
Buat masa sekarang ni okey doktor.
Okey, Nisha. Ni dah nak habis dah ni. Nisha okey ke? Nisha, where are you from Nisha? Nisha daripada mana tadi? Seremban Nisha Penang Nisha dengar ke? Where is Nisha? Nisha dah tak ada? Dah left. Nisha, mana Nisha? Nisha SKMB. Mana Nisha ni? Where are you Nisha? Okay, this is for plane XZ tu. Plane XZ sama approach. Okay, draw the shear and moment diagram for plane XZ. Okay, so Nisha. Nur Hanani ada lagi ke tak? Hanani. Nurul Najiha ada ke? Nurul Sarah tak ada Cuma Nur ni. Tamil Swaran. Okey ke tak okey?
Yes doktor, okay.
Tanish, okey ke Tanish?
Clear doktor, clear.
Okay, so this kind of problem nanti kita akan tengok lagi some more example and the real calculation. Okay, so this is for today punya dulu lah. Okay, so that's it for today. Thank you very much. Okay, so anything you can PM me later. Okay, anything you would like to ask or find out, okay, boleh message saya nanti. Okay, so this is the end of the first session. Nanti saya akan hopefully post semua apa ni, some information, the course information, the timetable, apa, some probably lecture slide juga nanti dekat e-learning. Okay, because nanti test semua, assignment dan quizzes will be online. Will be at e-learning juga, at e-learning. Okay, we're going to utilize e-learning. Okay, so thank you very much for joining. Sorry for any inconvenience. We'll see you again